Hello, today we're going to learn about binomial expansions, and from this knowledge we're going to solve one of the AS Maths questions from one of their papers. The paper we're looking at today is October-November 2000. Ooh, I'm sitting here on a beach in New Zealand teaching you this. It's one of the most beautiful spots in the country and in the world. And this is a beach on the east coast of New Zealand. Anyway, the paper we're looking at today is October-November 2024. It's the AS Maths paper. It's 9709/11. And what it asks us to do is to find the positive constant k in this expression here, where the term independent of x is equal to 150. We also have to determine the coefficient of x squared in this expansion for that value of k. Now the formula for the general expression and general expansion of a plus b to the n is ncr times a to the n minus r b to the r, where ncr is equal to n factorial divided by n minus r factorial r factorial. We call this the term in b to the r. There it is right there. Please put these formulae into your question answer book and learn them. In this particular case, the first term is kx in the expansion, so we're going to let a equal kx, and the second term b is 2 over x. So the general term becomes 4cr times kx to the 4 minus r times 2 over x to the r. That simplifies according to our index laws. You see this part comes to k to the 4 minus r times x to the 4 minus r times 2 to the r over x to the minus r, because x is in the bottom there. And in turn that simplifies to 4cr times k to the 4 minus r times x to the 4 minus r times 2 to the r. Why is it x to the 4 minus r? Because you've got x to the 4 minus r there, and you've got x to the minus r there, and the index laws require us to add the indices, so 4 minus r plus minus r comes to 4 minus 2r. Now the term independent of x has no x's, and therefore the coefficient of x has to be 0. Coefficient of x in this case is 4 minus 2r. So if that's 0, we have x to the 0, and it means we have a constant term, because that's 1, that's some number, that's another number, and we have a constant. So putting 4 minus 2r equal to 0, we now have r equals 2. So to find the term independent of x, we just have to put r equals 2 into our expression here. Doing that gives us 4c2 times k squared times x to the 0 times 2 squared. And of course the x to the 0 is just 1, so that whole thing simplifies to 24x squared. So 24x squared is the term independent of x, having no x's. But from the question we are told that the term independent of x is 150. Therefore 24x squared must equal 150, which means k squared equals 150 over 24, which simplifies to 25 over 4, which means k equals 5 over 2. Normally in this equation we would have k equals minus 5 over 2 as well, but we're told back in the question that k is a positive constant, so we're going to ignore the minus 5 over 2 answer. And that is the correct answer from Cambridge's answer sheet. To solve the last part of the question, we have to determine the coefficient of x squared in the expansion. The general term, remember, is this, which we got from back over here for our specific case. And so to get the term in x squared, we're going to need this part to equal 2. Putting 4 minus 2r equals 2, that reduces to r equals 1. So the term now becomes, this term now becomes 4c1 times k to the 4 minus 1 times x to the 4 minus 2 times 2 to the 1. Now k equals 5 over 2 we discovered before, so we substitute k into here, and we have 4, because 4c1 is 4, times 5 over 2 cubed, times x squared, which is nice because that's what we want, times 2 to the 1. Simplifying all that, we come down to 125x squared, and so the coefficient of x squared in the expansion is 125, which is the correct answer. Thank you very much for watching. We look forward to presenting you with some more of these videos shortly.